Meeting the world's growing demand for energy while reducing our impact on the planet is one of the defining challenges of the 21st century. A challenge that demands not just innovative technologies and materials, but new ways of thinking, new business models, policies and regulations, and a new approach to energy infrastructure. At Energy Futures Lab, Imperial College London's Global Energy Institute, we bring together world-class science, engineering and policy expertise to carry out research that transcends disciplinary boundaries to find systemic solutions for a sustainable energy future. Working in partnership with industry and governments, we drive technological innovation that has real-world impact and help to shape the policy landscape through high-quality evidence and advocacy for positive change. Through our internationally unique master's degree programme and regular events and opportunities for early career researchers, we aim to inspire and enable future leaders of the energy sector. Together, we're helping to accelerate the clean energy transition and build a secure and sustainable energy future that delivers for everyone. To find out more about Energy Futures Lab, our upcoming events or energy research at Imperial College, visit our website imperial.ac.uk/Energy Futures Lab.
Hello everyone, I'm Tim Green, and on behalf of the Energy Futures Lab, I'd like to welcome you to this year's Dennis Sanderson Lecture. We are delighted so many of you could join us this afternoon. In a moment, I'll hand over to Professor Rob Gross. He is Director of the UK Energy Research Centre and a Director of Imperial College London's Centre for Energy Policy and Technology. Rob will be chairing this afternoon's event and will introduce our speaker. But before we begin, just a few pieces of housekeeping. So first of all, the event will last an hour and a half, and there'll be a short break between the lecture and the Q&A session. Just before the break, we'll open up the question and answer box, and you're invited to ask some questions. And that box is on the right-hand side of your screen. We have several hundred attendees with us this afternoon, so unfortunately we won't be able to get to questions from all of you. So please give a thumbs up to questions that you see and that you'd particularly like our speaker to address, and we'll endeavour to get to those first. Finally, this event is being recorded and will be available on our YouTube channel soon. And we'd encourage you to share the recording with colleagues who weren't able to make it along today. And with that, I'll hand over to Professor Rob Gross to get us underway.
Great. Thanks very much, Tim, for that introduction. And welcome to Chris. I've not seen the video before, actually, so I'm very impressed. I love a little shiny promotional video. That's really great stuff. Before I get on to say a few words of introduction about Chris, I just wanted to say a few words about the person in whose name we have been running this lecture series now. I think this is the 11th year. Dennis Anderson. I wrote myself some notes about this just before the session got underway, but of course Teams promptly caused my computer to crash, and so I'd lost them. So I'm going to be just going to ad-lib my way through this. For those of you that remember Dennis, some of this will be extremely familiar to you. I mean, Dennis came up through the ranks in the energy industry. He was chief economist at Shell. He had a stint at the World Bank. He worked at what was, I think, the Ministry of Mining and Power or something back in the 60s in the UK. And he always had this tremendous vision of the potential for policy to promote innovation to solve environmental problems. And I think that was a huge inspiration to me at in the beginning of my career, of just how powerful some of the policy tools we have can be to affect change. Now, sadly, Dennis passed away just after the publication of the Stern Review, into which he had quite a significant input, and so didn't see the Climate Change Act and the creation of the Committee on Climate Change and all of the tremendous progress that we've seen in the last 12 years or so. But I would say, I think that were he around today, he would be so excited about what Chris has got to talk to us about today, and about the vision and the excitement, I think, that we've got around the sixth carbon budget, and the role that the Committee on Climate Change Committee, I should now say, is playing. Okay, so I mean, Chris is really delighted to have Chris along this afternoon. Chris is the Chief Executive of the Committee on Climate Change, which is a non-departmental public body. It's the advisor, if you like, on all things to do with our carbon budgets and climate change policy, as well as being a bit like an advisor and a policeman, because the committee also has the responsibility to report to Parliament on how well government is doing in meeting our carbon aspirations. So Chris leads a team of analysts and specialists doing all sorts of wonderful work. Chris led the CCC's work in 2019, of course, recommending what was then, I think, a world first net zero target for the UK. And he's got a lot of experience in Treasury and in the Department for Bays and its predecessors, as well as in the Scottish Government. So without any further ado, I'm going to stop babbling at you, hand over to Chris. As Tim said, we're running now for about 45 minutes or so. Hold off your questions because we haven't activated the question box yet. Then we'll have a short break and then we'll do the Q&A. Chris, thanks very much and welcome.
Thanks, Rob. Can I check you can hear me?
Yes, absolutely.
Great. And can I check you can see some slides? That's the next question.
Yes, we can.
Wonderful. And hopefully you'll see them in the brand new branding of the Climate Change Committee, which I'm pleased that Rob stumbled over. So we have recently changed our name, and we have we moved on a little from being the Committee on Climate Change, which was a mouthful of a name that very few people could get right, into the Climate Change Committee, which is what people have been calling us for years. So we've moved on from that, and we tried to relaunch ourselves with the report that we published last week, and I am going to talk about that mainly today. But let me just start by thanking you, Rob and Tim, for inviting me to give this lecture this afternoon in some, of course, very strange circumstances. I did not think when I sat in the pub with Rob at what I think was the start of this year, could have been last year even, talking about whether I would do this lecture, that I would be sitting in my front room in Glasgow delivering it. So, but here we are. But I wanted to just start with some reflections on Dennis Anderson. I've enjoyed myself reading about Dennis, and he knew a thing or two about energy and about the economy. And I think about societal transitions. That we all know about how distinguished his career was, and Rob covered off some of the things he's done. It's an amazing CV. More important than that, the thing that caught my eye was he's the son of a Sheffield coalman. And that's a big theme, I think, of what I'm going to talk about today. We are all sons and daughters of the fossil fuel industry. So I am talking to you, as I mentioned, from Glasgow today. It still amazes me to say that next year we'll be entertaining world leaders at the next major climate summit in Glasgow. This is a city that was very much founded on fossil fuels. In fact, every modern industry around us is founded on fossil fuels. It's totally woven into the fabric of modern society. And that just isn't sustainable. And you all know that. It never was. And just as Sheffield coal mining wasn't sustainable, we're going to have to find a way to pivot away from fossil fuels. And that's what this lecture is about. So the great pivot, if I can put it that way, the decisive transition that's ahead of us. I am simultaneously very, very worried about the rate at which our climate is now changing. And on the other side of the coin, unashamedly optimistic about our ability to arrest the decline in the state of the climate. Why, you might ask, and it's a combination of seeing the economics move inexorably towards decarbonisation and away from fossil fuel use, and my hard belief that eventually this problem of climate change, climate breakdown, is going to come to dominate all others if we don't address it. It's going to become a real issue to politicians, and I think we're already seeing that in the recent US elections, for example, and around the world. China is not immune to it, it's responding to it. It's happening now. So more controversially, it's also my belief that the UK has a role in pointing the way out from our use of fossil fuels globally, and that's what I'm here to talk about today in the main. So let's talk firstly about what I'm going to cover. I'm just going to do 5 minutes or so on each of these topics, try and build a story overall about the progress that we need to make on climate change, and especially looking at the issues from the UK perspective. I'm going to use the plethora of new materials that we published last week in our report that Rob mentioned at the top of this presentation on the 6th carbon budget advice. I'll explain all this later on, but please delve into that. It's on our website. We have never produced anything as detailed as the recent report. There's also some nice tools to play with the data that I'll be talking about today as well. If you're interested in that, delve into it now if you find any of this boring, of course. So it's all there. It's an amazing body of work, and I'm very proud of it. I'm going to use some of it today. I'm going to touch on policy throughout this lecture, but it's not really a policy lecture, so probably best to save questions about policy till later. Instead, what I'm going to try and do today is explain the extraordinary changes that lie ahead of us here in the UK if we're going to get to that goal of net zero emissions that we advised was the appropriate goal last year, and which is now the statutory target for the UK. Extraordinary changes, but the other message here is that they are entirely feasible. So that's an amazing thing to be able to talk about. Hopefully you'll see why at the end of this lecture. And above all, feasible, yes, but extremely attractive. And actually, these are steps that we should be taking, not just because they will help address the climate issues, but because they're the right thing to do for the UK economy as well. So if we approach this task in the right way, this is an immensely feasible and optimistic and exciting and attractive set of changes that lie ahead of us. So before we get into that, I want to start, as you should always do, at the beginning, and begin with a sobering, if I can put it that way, reminder of where we really are on climate. So this is not going to be a science lecture. I wouldn't be the person to deliver it if it was, but the key issue here is about our concentration, the concentration of CO2 in the global atmosphere. That is the issue at hand. That's the global issue of climate change. The issue here is the concentration of CO2 in the atmosphere has an impact on temperature. CO2 particles trap infrared radiation that would otherwise escape, warm the planet, and those CO2 particles are very long-lived. So once they're up there in the atmosphere, they take a long time to come back down again. So the crucial thing here is there is a linear relationship, near linear relationship between the stock of CO2 in the world's atmosphere and the temperature on the planet. And we have a brilliant record of the accumulation of CO2 in the atmosphere from the bubbles that are trapped in ice cores. So we can look at that here. This is 800,000 years of ice core data looking at the CO2 concentration. In more recent years, we've actually been sampling that live. This is the data from the observatory in Hawaii, where we make regular samples of CO2 from 1958 onwards. But what you see here is nearly 1 million years of CO2 concentration, and that kind of natural cycle over that 1 million years in the change in CO2. If I just roll this on to the present day, I beg your pardon, go back one there, then hopefully you'll be able to see in this next chart, beg your pardon, it's not going to work, never mind, that line would take us right over in present data the 410 parts per million. That's where we are today. 410 parts per million in the global atmosphere today, the highest that it's probably been for 3 million years. 3 million years ago, when we last had CO2 concentrations at that kind of level. 3 million years ago, we had sea levels that were probably 20 meters higher than they are today. So really astonishing change in the global climate that we are now witnessing, and that's today. So even in a year like today, when we have an unprecedented slowdown in the economy, we are growing the concentration of CO2 in the world's atmosphere, and therefore growing the energy in the world's climate system and the temperature increase that will follow. That has consequences, as you might imagine. So let's just move on, if we can, to the next chart, which is just going to show us where we are headed now with that global concentration of CO2 in our atmosphere. And even if we are optimistic in our projections about where that's heading. This is looking at the commitments that we've got for 2030 and onwards in the current NDCs globally. What you can see in this chart is that temperatures are going to continue to increase from where they are today. And current projections, we're looking at something more like a 3 degrees of warming by the end of the century. That would be catastrophic for the global economy, for biodiversity, crucially for people's lives around the world. Now, you knew all of that. It's having real impacts here in the UK as well. We are seeing temperatures rising in the UK today. At the moment, we've risen temperatures by about 1 degree centigrade over pre-industry levels. Some parts of the world have seen much more than that. I could show you lots of nice photos of ice poles and the disappearing ice and extreme heat in the global south. There is a story playing out in the UK as well about the change in climate, and it's having a real impact here today. So today, as we talk, annual temperatures are about 1.2 degrees centigrade above pre-industry levels. We've experienced about a 0.8 degree centigrade increase since the 1960s alone. So that's changing the seasons here in the UK. Heat waves now more likely. Summer temperatures have been creeping up appreciably in my own lifetime. I'm 42 years old. 35 degrees centigrade is becoming increasingly common in the southeast. By the end of this century, we're expecting, even in places in the north, that we'll be regularly exceeding 30 degrees centigrade during the daytime. So at least once a decade for that kind of heat wave coming along. These are unprecedented changes. We have the UK record temperature is just under 39 degrees centigrade set in 2019. I fully expect that 40 degrees will be breached at some point in the UK. So we're not talking about a change that's playing out in other parts of the world. It's happening here in the UK as well, and we're not well adapted to those changes. These changes add up, they add costs. The UK is one of the least affected places in the world, and yet these big changes are happening here now. And these are the costs that Dennis Anderson pointed to in his work on the Stern Review, of course, as well. They are real and they are here, and they must be addressed. So the question then is, what can we do about this? And here we go on to the really interesting stuff. So we need to now talk about the Paris Agreement. And what the Paris Agreement talked about was keeping temperatures to well below 2 degrees centigrade with best efforts to 1.5. And what you see here is the implication of those temperature targets translated into emissions goals globally. So what you see here is a handbrake turn in global emissions after the black historical line. You can see that the red line and the blue line take us to net zero. The red line here is 2 degrees, so well below 2, which is how Paris expresses it. The blue or purple line is best efforts for 1.5. And what you can see on this chart is that the global goal is to get to net zero probably in the 2070s. I'm looking at here net zero for all greenhouse gas emissions. That's the implication of the Paris temperature targets. If you were to look at CO2 only, a different basis, you'd need to get to net zero at an earlier date. So 1.5 degrees, that magical temperature threshold that we've been discussing so often, probably rests on achieving net zero CO2 by 2050 or thereabouts. And if I just add to that the UK target, hopefully you can see that there on that line. That gives you a measure of how much more ambitious the UK is being than the global requirements of Paris. Again, this is for all greenhouse gas emissions. If we were to look at the CO2 only chart, the UK would need to get to net zero on its own target of 2050 for net zero for all greenhouse gases. We'd be getting to net zero CO2 somewhere in the 2040s to meet that. And just to give you a sense of what that would imply then, were the world to go on that kind of rapid decarbonisation strategy, which is of course what Paris implies. This is drawn from the IPCC's special report on 1.5 degrees from a couple of years back. You'll see that we have temperatures peaking just over 1.5 degrees and then falling back down on that kind of emissions trajectory. We've also included some of the Earth system feedbacks here, that the melting of the ice to release methane, for example. You see that in the green line here. So note the plumes on this chart. This is the highly optimistic take on how quickly we can cut emissions globally and the impact that will have on global temperatures. But you can see that there's quite a bit of potential error in that kind of median line that we've talked about. Still, we have higher temperatures on the table, even if we have those kind of rapid temperature emissions reductions that we've been talking about in this opening section. That implies we should really act now. The precautionary principle means we should be cutting our emissions as quickly as possible. So what we're going to talk about next is how we can cut emissions as quickly as possible, and crucially what the UK's role is in that story overall. So I want to just go back now to talk about my institution, the Climate Change Committee, the CCC. And Rob mentioned some of this at the top of the presentation. We were established by the UK's climate law, that's the Climate Change Act, in 2008. We are now the nation's advisors on climate change. We're not part of government, so instead we stand close to it, but we're independent of it so that we can advise Parliament, we can advise government, we can advise people living in this country about the targets and the policies that are necessary to cut carbon and to meet the statutory goals that are contained within the Climate Change Act. We also scrutinise progress, as Rob talked about. Now, I've been doing this job, the Chief Exec job, since about 3 years ago. And it is a genuine privilege to have this job, of course. Above all, though, I think my task is to ensure I don't break this wonderful institutional system that we have in the UK for addressing climate change. The CCC, I think, has been a really wonderful addition to the framework of things that's been driving progress on emissions and on climate change in the UK over the last 12 and 15 years. I have the luxury today in a slightly longer lecture to be able to delve into how we go about that task. So I thought I would kick off with just something on that. So just something on how we approach the task of advising on how we cut emissions. We start from the climate science, which, as we've just talked about, requires a very sharp fall in global emissions and a sharp fall, therefore, in UK emissions. We look also at the international circumstances, what others are doing around the world. That has been changing recently. Last year, we gave advice that the UK should set this net zero goal by 2050, and others have followed. And that was part of the advice that we, when we said last year that it was necessary for the UK to go ahead and set that goal, we said that others would feel the need to respond, and they have, and that's great. But what else we do, and this is the really interesting stuff that we've been talking about in the last week or so, is that we advise on these things, the carbon budgets. These are the interim targets for UK emissions that we set every 5 years. And we give the advice to government on what those targets should be. It's the government's job to turn their recommendation into a legislated target, and they will do that next year. The way that we do that is by building up this kind of sector-based approach to carbon abatement. So we look across the power sector, we look at industry, transport, agriculture, buildings as well. And we look at the question of how we can build bottom up a set of steps, measures, understanding of how you can cut carbon across the economy. We try and do that in a way that stitches together those sectors, so we get this kind of systems outlook on the challenge of cutting emissions. And we use that to build these UK carbon budgets, the glide path to the long-term goal. The thing we've just advised on is the 6th carbon budget. That's the period from 2033 to 37. I think this will probably be the most important ever of the carbon budgets. I don't think there will be another one that's quite as important as the 6th, because it's the first that's been set on the way to the new long-term goal of net zero. And it will therefore determine the shape of the chart from now on in. And that's what we're going to be talking about next. But we do a bit more than that. We also look at the impacts of that, and we're going to talk a bit about that today too, and we're required to do that by law. So it's not just about cutting carbon. We also think about the social impacts and the economic impacts of that, and we try and minimise the costs to society across those sets of issues that you see in blue there. And that's the really exciting part of our job. If we were driven only by carbon, then we'd have probably a different outlook on how quickly you could cut carbon across the economy and the radical steps potentially that you would need to take to deliver that. And today I just want to bring in one extra thing, which I think is the real step forward in the work that we've done recently. The new aspect of the work that was published last week is our very real world constraint on the pace of progress, and that's about asset lives. So we've always considered what we call asset turnover, the need to turn from high carbon to low carbon technologies progressively over the coming years. But in the most recent report on the 6th carbon budget advice, we've really started to lift the prominence of asset turnover as a determinant, a key determinant of success in UK decarbonisation. Ideally, this transition to zero carbon that the UK is now committed to is going to be well managed and as inexpensive as possible, minimum of fuss. So to do that, what we really need to do is engineer the turnover of capital assets as much as possible at the end of their useful life. And just look at that list that I brought for you there, if you can see it. We're really up against it. If you look at some of the numbers in that list, I've just highlighted a few there. If you think about 2050 and then think about the lifetime of assets bought today, then you can see that the average across this whole list is something between 15 and 20 years. That implies really sharp action now to address the need to phase out the sale of high carbon assets pretty damn quickly if we're going to make that goal of 2050 on time. So if we want to do this in the way that minimises that fuss I was talking about, we have to think about these asset lives and make sure that we are in a position when an asset comes to the end of its natural life to replace it with a low carbon version. We have an alternative approach to this, which is to start scrapping assets early, stranding assets. That tends to be a more expensive strategy in the long run and not one that carries high public or commercial support, of course, as well. So this has been a bigger impact on our analysis than recent assessments have had. And I think it's a really good way of imagining how we need to get to the 2050 goal and imagining, of course, how urgent that task now is if you look at some of the lifetimes of those assets that you see on that list there. The other thing we've been doing is building a more rich assessment of how to get to net zero. And I won't dwell on this. Any of you who've had the chance to think about what we talked about last week, you'll see that we've got 3 illustrative scenarios for how the UK can get to net zero, which we built, again, bottom up, looking at a set of changes across the economy to deliver net zero. Each of these is a self-contained scenario, so it gets to net zero under its own steam, but each of them explores a different type of transition. So headwinds is similar to what we said last year. It rests very much on big infrastructure provision. It's a world with lots of hydrogen and CCS in it. Widespread engagement is a scenario where people are more responsive to the need to cut carbon. Businesses too respond more sharply. And the blue one, which is actually, I think, probably the most interesting of the scenarios, is where we see more innovation, more technological innovation, also a cheap power price overall, which drives people to adopt electrified devices across the economy more readily. We also, in that scenario, have some of the devices that might, through technological means alone, take carbon from the atmosphere, suck it out, the direct air capture that we has occasionally been talked about as one of the climate solutions. That comes about because the power price is so cheap that those machines can be used economically. And we've also managed to build a 4th scenario, which is really exciting, one that we were very keen to build this year in our work, which is the highly optimistic scenario. What happens if you get everything going well? It's not one, sadly, that we can just take off the shelf. You have to believe that everything is going to go well. We get the best of the innovation scenario, the best of the infrastructure provision, we get the best of the behavioural change. That maximum effort gets to net zero by 2042, so earlier than 2050, but only shaves 8 years off the statutory target. More than anything, I think that scenario demonstrates that we have an ambitious target in place already. So 2050 is the right target for the UK, if you buy my argument that we have to manage this well. Tailwind sets out, I suppose, the parameters of the exercise. It may be possible to go faster, but of course that rests on early action. And the 5th scenario, the one that we'll be talking about for the remainder of this lecture, is what we call the balanced pathway. And that is one that we've designed deliberately to give a more balanced set of changes across the economy in each sector of the economy. You can view that, you can look at the changes that we are advocating in transport, in buildings, in industry, in power, in agriculture and land use. What we're trying to do here is drive progress through the 2020s and then explore and keep open the exploratory scenarios that I've just talked about through the 2030s and beyond. It may be possible to go faster later, but this is the right strategy for now, is our central message. This is a really ambitious take on what needs to come next. It's of course very challenging, also very feasible, and I think very appealing too. This is the scenario that we use to make our recommendations to government. So let's move on then to what we are recommending for the UK, and we'll get into the really interesting stuff now. So this was the central chart that we used last week when we launched the 6th carbon budget. This shows you our balanced pathway. You can see the 6th carbon budget period that I was talking about in the mid-2030s in orange. We are recommending that the UK should set a target for cutting emissions that's equivalent to 78% reduction on the 1990 baseline by 2035. Now, the importance of that is that last year, until June last year, when the UK legislated a net zero target by 2050, the target we had was an 80% target by 2050. So what we are effectively saying in our recommendations is that the UK should bring forward the target that we had 18 months ago by 15 years. That is, a measure of how ambitious we are being by setting net zero as the goal. And that, that faster pace of emissions reduction is really important, of course, to the global goals. We're going to need to achieve a faster pace of emissions over the next 30 years than we did in the last 30. If we're going to make that kind of goal and that trajectory to net zero. It's a front-loaded path. If you divide up the next 30 years into two 15-year periods, it would be a 60-40 split in terms of the emissions reduction. That front-loaded path is really, really important, we think. It's important because it requires us to invest early. That can support the economic recovery. It opens up the options, of course, not just the options for emissions reduction, but also the options to build new industries, new employment opportunities. And crucially, back to the Paris goals, we're minimising cumulative emissions by going early, and that's essential to meet the Paris obligations. Something we didn't talk about last week, but this just shows you the illustrative scenarios for net zero that I've just talked about. You can see the three of them there. And then if I overlay on top of that the tailwind scenario, you can see how that gets to net zero slightly earlier. You can see that it starts to build up, that trajectory starts to drop away over the 2030s and 2040s for tailwinds. But if I just put on top of that the balance pathway, which cuts its way through all of them. For me, the really interesting thing about all of those emissions pathways for the 5 scenarios that I've just talked about is that despite the fact that they are dramatically different in their nature, so within the sectors you're making very different choices about how, for example, you decarbonise the energy system, they have a similar shape. So if you look at the shape there, what you see is this kind of inverted S curve over time, which I think tells a story about what needs to happen next in the UK and also what we've come from. So you see the early part of that transition, which you can see really well on this chart. The progress on emissions reduction is actually quite slow. And the reason for that is that we haven't really been making enough progress outside of the power sector to drive up the pace of emissions reduction. So we're going to run out of coal-fired power plants to close very shortly, and that's a great story for the UK. But it means that that low-hanging fruit in the power sector is not there anymore, and we're now scrambling to make up in other sectors for the emissions reduction that is necessary. So you see that in that early part of the curve, we are not, despite a very ambitious strategy that I'll talk about in a second, we don't see that sharp emissions reduction. Then we see over the 2030s, it starts to drop more rapidly. And then by 2040, it tails off again as we wring the last of the emissions reductions out. That's the story that the UK will need to see play out. It's not just a story in the UK, it's other countries around the world that will see that similar S curve as we scale up the ambition. And that's what I want to talk about next, is just to talk about how we deliver that kind of S-shaped outcome. And let's move on then to delivering net zero in the UK. This is my favourite chart. We call this the rainbow chart in the CCC. This explains the carbon abatements that we have to achieve to get to net zero, and you can see that quite neatly characterises in 4 ways, 4 strips on the rainbow. So the purpley ones at the top are about reducing our things, the things that drive emissions at the moment. So that means reducing demand for carbon-intensive things like red meat or flights. It could also mean more efficiency, so getting more from less. So big message in here about insulating your home more, being comfortable with using less energy overall. The importance of that purple line is that it's more important in the short term than in the long term. So you can see that the progress on emissions reduction in large part rests on reducing our demand for high carbon goods over the next 5 to 10 years. By 2050, it's a smaller part of the overall emissions reduction. The next bit, number 2, is our take up of low carbon solutions. So the red, the orange and the yellow here are about adopting low carbon technologies. That could be electric cars, could be heat pumps to keep us warm in the future, might also be hydrogen or carbon capture. The biggest wedge there is the orange one. So it's the electrification wedge. That's what we see as being the most important part of the UK strategy overall. We've always said that, but you can see that really clearly here. That's doing a lot of the heavy lifting. That's us adopting electrical devices and increasingly moving away from fossil fuels, particularly in transport. Number 3 is the expansion of low carbon energy. That blue wedge there is the further decarbonisation of our power sector. We need those low carbon fuels to run all these technologies in the red wedges above that. The blue here is about expanding our supplies of low carbon electricity, finishing off the job of fully decarbonising it, and in time building low carbon hydrogen. And finally, the green stripe is the reminder that this isn't just energy. So this is the natural stores of carbon that we need to build over time as well, so that we can get rid of the emissions that are in the atmosphere. This is the net bit in net zero, if you like. This is about us actively removing CO2 in the atmosphere by planting trees, planting new energy crops, which we think we can use then in carbon capture and with carbon capture and storage, and use those to permanently bury under the sea. So that's the plan overall, that's the rainbow chart. Here's another take on that. This is the sectoral contribution, and I'm not going to go through all this, but just to make the point that each sector contributes something to that overall goal. The message here is there's a vast variety of things happening across the sectors of the UK economy to get to net zero. We haven't just got a ruler out and drawn a straight line. It's a product of very deep consideration of how you build up to that net zero outcome in each sector, in each corner of society to get the outcome that we need, putting the policies in place, building the supply chains, getting that reaction then from consumers and businesses to drive emissions down. Genuinely cross-sectoral. I just want to pull out one of those lines if I could, which is the industry line, which this year we're calling manufacturing and construction. Just to draw out the story there, this is the line that's changed most since 5 years ago when we gave our advice on the 5th carbon budget. If you look at the change in the 2030 target that we advocated, so the NDC for UK emissions with the Prime Minister put into the UN process just at the weekend, 75% in the change in the 2030 target for UK emissions comes from industry emissions alone. 40% of the change by 2035 is accounted for by industry. So this is a big step forward for us. This is the new part of the modelling in the CCC. We're really moving away now from discussing industry as being an area where we've got hard to treat problems. That comes with it. There's an important story about the need to decarbonise industry, not just get rid of it. So there's a big message in this report about the need to keep industry competitive and low carbon. And you'll see in a second that the big challenge here is to protect industry from some of the costs of that decarbonisation overall, so that we don't just lose it, which isn't good for the economy or for the environment. And the last of these cross-sectoral discussions is I think one of the other charts that people seem to really like from work we did last year, which is looking at behaviour change and the role of technology. Now, what we've got here is the abatement to 2035, and what proportion of that is made up by industry, by technology alone versus behaviour change. 40% of the emissions saved come through pure technological shifts, so swapping a fuel or closing a coal-fired power plant, as we've just discussed. The crucial thing is that that purple wedge there, technological solutions, these are the things that people don't tend to notice, tend to be more centrally planned, the sort of thing that policy can really affect easily. The rest of it, the pink wedge and the orange wedge on that pie chart, involves some element of behaviour shift. So you got well over half of the emissions reductions necessary for the 2035 goal that we are recommending come with behavioural shifts. Some of that's pure behaviour, so that's changing diet, for example, or flying less. You see that in the orange section there. The really interesting bit for me, at least, is in the pink section. So more than 40% of emissions reduction in that section, and that involves a combination of technology and behaviour. This is the bit I think we are not talking about enough. So this is nothing at all to be afraid of, but it's quite fundamental changes potentially that involve some explanation, I think, to the people of this country about what's coming next. I don't think we should be afraid about any of this. The phrase I've been using a lot recently is this is the stuff that's a change, but not one that's major. So you might be plugging in your car by 2035 rather than taking it down to a petrol station. I hope many of you will be heating your home without using fossil fuels by that point, but you'll still have a warm home. Those sorts of changes are necessary to get to the goal of net zero, to get to the 6th carbon budget goal, but we haven't been discussing them enough. So the lesson here from the recent Climate Assembly, which we helped to support and has some really dynamite insights, that was a group of 100 or so people selected from the electoral roll in the UK to be representative of UK people, is that when you give them the tools to start considering this stuff, when they have the understanding of what's coming next, they're really supportive of it. But most of them didn't know what was next, what was coming, because they're not steeped in these climate issues. So a really important message about the need to engage people in the changes that are coming next to get to net zero. So all of that's fascinating. What we wanted to do, though, beyond that was to try and build a much better story about how things actually change over time in the UK. So let's go on to that journey now, and let's talk about the timeline of changes that lies ahead for the UK. So we're going to begin in 2019. By 2019, we've reduced from 1990, we've reduced UK's territorial emissions by 41%. And we haven't had a pandemic yet, so we need to talk about COVID now. Sadly, we always have to talk about COVID at some point. The big impact on emissions will come from COVID, we know that. So this is going to be a year like no other. So we're going to see a very sharp reduction in emissions from the pandemic and the lockdown that we've used to treat it. But we are not assuming that those effects last. So crucially, we're not assuming that COVID is going to reduce emissions permanently. It may prove to do so, but that wasn't part of our analysis. So everything comes back to trend in our analysis. That's us making it truly prudent in our outlook. We don't assume that everything returns to trend immediately. So for example, aviation emissions take 4 or 5 years to get back to trend, but they all get back to trend in the end. And that's very important. I'm labouring this point because what comes next is not about a pandemic. It's about systemic change. It's the things that we need to do to change on a permanent basis the emissions that the UK is producing territorially. So to do that, we're going to have to scale up from now on the policy commitments, the strategies, the delivery mechanisms to deliver a sharper emissions fall along that trajectory that we talked about. These are going to be fleshed out in all of the things that are coming. So we've seen the 10-point plan from the Prime Minister, the Energy White Paper, a whole host of things promised before November next year, which I won't go into here. But these are the things that are going to take us on the next part of this journey. So if we move on to 2025, and let me see if I can get that working. There we go, got it working again. So on to 2025. By this point, we're making good progress across all areas, but as I mentioned, we're not yet seeing the emissions reduction. So coal's been phased out of the system by 2025, so 2024, we're expecting that to happen for the power system in the UK. We started to construct homes to what we call the Future Homes Standard. So that's the kind of standard that we need to have met and should have met several years ago, this zero carbon standard that we should have met years ago. We've got just under a third of boiler replacements by this point, so 5 years away, already low carbon. Any new boilers from 2025 onwards that are being sold, we think should be hydrogen ready, which opens up the option of hydrogen later. That doesn't mean that the hydrogen conversion is the central strategy here, but we need to keep open that option if we think hydrogen is going to be in the table. They've got some changes in consumption here. So meat consumption's fallen by 10% over the next 5 years. 30,000 hectares of new woodland have been planted each year by this point, driven especially by DEFRA's reforms. Half of new sales of cars and vans are electric by this point. And we started trials of zero carbon HGVs. We've also got new business models in place for hydrogen production, really important. Also carbon capture and also greenhouse gas removals over the next 5 years. This is the challenge for this Parliament. Adam, I mentioned we're not seeing the emissions reduction yet, but you're going to see the scale up that comes after all of that if those policies are put in place in the next section. Scaling up, though, is that theme. So by the mid-2020s, you really are talking about scaling up across the economy, scaling up the hydrogen production, scaling up offshore wind, scaling up heat pump installations. That's a theme we'll return to. Scaling up electric vehicle infrastructure. First carbon capture installations and clusters happening across the UK. We've got the switch from fossil fuels happening in manufacturing to those clean fuels, hydrogen and electricity as well. Let's move on then to 2030. Let's pick up the pace now. So emissions have now down by 2/3 from 1990 thereabouts. 2030 is really the key point. So by that point, we moved from scaling up the policy to rolling out the investments as the strategy for the UK. The decade prior has been about policy and strategy. The new commitments that come from that, the new incentives that come from that are really going to start playing a big role over the 2030s. So let's see how that looks. By 2030, almost 100% of sales, so 98% of sales of cars and vans are battery electric. Hybrid, we think, will be a very niche thing, or at least needs to be to meet the goal. We've got 1 million heat pump installations happening each year by 2030. So think of that challenge. We're probably only doing 20 or 30,000 a year right now. New sales of oil and coal heating have ended in homes. For rented homes, we've got them achieving an energy performance certificate of C. thanks to an accumulation of 11 million insulation measures that have been fitted by 2030. We've got 40 gigawatts of offshore wind. We've got at least 5 low carbon industrial clusters doing serious CO2 capture, so 10 million tonnes of CO2 a year. We've also got 30 terawatt hours of hydrogen production, commercial scale greenhouse gas removals happening. Meat consumption's down by 1/5, and that's driving a transformation in agriculture, so freeing up agricultural land so we can plant trees and restore peatland. If we move on to 2035, this is really the key date for me. This is the critical moment, which is just 15 years away. Maximum momentum now on cutting emissions. Emissions have really started to fall by this point. They're falling fast. 4/5 reduction since 1990. That's a fall of about 2/3 from today. Just think about that. You can see what's driving that progress on the right. So the electricity supply is now half bigger than it is today. We've got entirely low carbon electricity systems. So we phased out natural gas, unabated natural gas use in the power system. That's the Joe Biden date as well in the US. Got sales of natural gas boilers to all homes, which are now, we have now got to the point where they've ended. So in 2033, we think the sale of natural gas boilers should end. For all other areas, it's going to be mainly, we think, heat pumps and for district heating, unless you're in an area that has been zoned for hydrogen. And that crucial task of zoning those areas, regional planning for the heat decarbonisation is what's been achieved over the next 15 years to allow that transition to happen in heat decarbonisation in buildings at scale. In industry, we've got zero carbon steel making. Hydrogen production is up at 100 terawatt hours a year. You've got widespread use of carbon capture and storage now, including from energy from waste plants. We've cut our meat consumption by 1/4 by that point. We might well be substituting with lab-grown meat by that point. And we're up to 50,000 hectares a year of new woodland creation and up to 60% of peatland restored as well. So the big biodiversity benefits to that too. And then the last part of my little timeline here is we get to 2050. By that point, we have offset entirely any residual emissions in aviation and in agriculture, especially. They're the two sectors we're expecting those continuing emissions. We've got a bit of further diet change, but the main story here is that we're now using all that low carbon electricity and low carbon hydrogen production really extensively throughout the economy. It's been completely normalised over the 2040s, and that really does need to be the plan, scaling this up so it's not novel. That's what we're going into some detail in the report that we published on how to do it. So there's a policy section that goes with all this that I really recommend. The exciting thing for me is that we see all this as feasible. So it can be done. I think it does, though, give you a sense of how big that challenge would be. So really important to say, I think anyone who thinks that 2050 as a target for net zero is not ambitious, I don't think they've really thought through those changes. That's not to say that we couldn't go faster, but it is an immense set of changes right across the economy that involves a huge amount of effort over the next 10 years, especially to get to the point where you can get that very sharp emissions reduction over the 2030s that we need. And I think that is really important. If I just whistle through the changes that we'll see alongside that, I'm not going to dwell on any of these. That's what's happening with carbon capture. We're doing less of that than we had in the net zero report last year, but we're still doing quite a lot of it. The black section is greenhouse gas removal, so BECCS, bioenergy with CCS. We think that's feasible, especially if it's paid for by those sectors that are still using fossil fuels, especially aviation. Purple section there is hydrogen production. Just an amazing set of charts to show you what happens with the energy transition now alongside that. So first, gas down a huge amount. This is the biggest change in our numbers last year. We are less reliance on natural gas. We've still got a bit of it, but we're doing it with carbon capture by 2050. That's all that's left, and we're doing that in the power sector mainly and in hydrogen production. The next one is oil, and just a similarly amazing chart on our oil demand. It falls very rapidly, first from light vehicles, then onto the larger vehicles. By 2050, we're really only using it in planes and jet fuel. So down 85% from where we are today. Next is hydrogen. So on the flip of that, these low carbon fuels that we need. Very, very big hydrogen sector develops from near nothing today. So that requires us to trial hydrogen over the next 10 years, of course, so that we build the demand for it over time, over the 2020s. By 2050, if it scales up according to this chart, then it will be about, in energy output terms, about 2/3 of the size of the electricity sector today. Really huge shift. It's mostly being used as a fuel in manufacturing as a replacement for natural gas, also in shipping, probably in an ammonia form. We expect the main source of that hydrogen initially to be blue hydrogen, so taking natural gas, reforming it and capturing the carbon. But increasingly over time, we're moving to green hydrogen using electrolysis for that supply. And then I wanted to end just on this energy chat on the stunning change that we see in electricity demand over that time. So we grow electricity demand by a half by 2035, and then we've more than doubled it by 2050 to replace most of that oil and gas demand that we have at the moment. That is a huge shift, not a huge surprise for anyone who's worked on this over time. The chart I like is the supply one, which I've just added in. I could have done a supply chart for all of these, but I thought I would just end on the electricity supply changes and just look at the change there. So that big section in pink that you see is in our balanced pathway, us reaching 80% of renewable supply of electricity, and then that electricity very much being the backbone of the whole energy system. So that's mostly offshore wind in our assessment. We've got over 100 gigawatts of offshore wind. Just under 100 gigawatts of offshore wind by 2050. Nuclear, you can see we call that firm power. Nuclear is in the orange section. Could easily, I mean, we talk about nuclear, it could easily be something else, which is why we use the term firm power. It could be something like CCS, but you see that doesn't change over time. It's pretty consistent, but we are expecting nuclear closures over that time. So we've got room in there for Hinkley Point, probably a Sizewell and possibly one other. And you can see hydrogen is also being used as a fuel for electricity generation in there progressively over the 2030s as well. So that's a replacement for where we use natural gas at the moment. But just a stunning change. And you can see a big change across the scenarios I talked about in electricity supply for that too. So some of them go even higher than 80% in terms of renewable supply. That innovation scenario has 90%. Now, onto the penultimate section of this lecture, and this is not a long section, but I did want to talk just briefly about the question of cost. And here I think we have a really exciting and optimistic story to tell about all this stuff. So we've talked about the changes that we see over time. What actually drives that is primarily a story about investment. But before we get to that, I want to just talk about innovation. Something that Dennis Anderson knew a lot about, of course. People quite regularly ask me why I'm optimistic about that handbrake turn in global emissions that we need to see to get to the Paris goals. And the reason is because the economic fundamentals are now pointing much more fundamentally towards low carbon and a declining interest in high carbon over time. And we need to talk here not just about innovation, but also disruption. So we know that this is standard stuff, that incumbents are replaced regularly by disruptors. Creative destruction is how the economists sometimes refer to that. That process in modern economies happens quickly. It's happening now in energy, which you can see, I think, in this chart. This chart is from actual data. This is levelized cost of energy from energy auction, electricity auctions from around the world. We are already at the point, as you can see on this chart, I hope, when the price of clean fossil fuel alternatives in the power sector is already beneath the range of fossil fuel prices in the future for power. So that's the impact of innovation playing out. That's the clean energy technologies that are coming along, undercutting on price the fossil fuel technologies. That's due to scale manufacturing. That's due to solar and wind technologies being produced at scale and being deployed at scale, especially through policy and market innovations that go with that. That's what's created this huge recipe for disruption in the energy sector. And we're already seeing that play out. So just imagine that story about electrification and this chart. This is a global chart, of course. We're benefiting in the UK from the offshore wind story that's playing out. But it's not just in the energy sector. We just roll on to another chart, another cracker that we produced last year and updated this year. It's also a recipe for disruption in the automotive sector. So what we're showing you here is the combination of cheaper and cheaper power being produced from zero carbon means. Cheaper batteries is what you're seeing on this chart too. Electric motors also that are much, much more energy efficient than internal combustion engines. And the scale manufacturing increasingly of those electric vehicles just drives down the unit cost of the vehicles. This is the whole cost of the phase out of fossil fuel cars versus the continuation of those sales. So what we're showing you here is that it is cheaper to decarbonize cars and vans, surface transport, than not. And that's stunning. It's cheaper in 2035 if that's your phase out date. It's cheaper still in 2032, and it's cheaper in 2030 still. So this is the innovation and the disruption that I just talked about. It's playing out right now. And the crucial point is that we think the price tipping point on that electric vehicle transition probably comes in the late 2020s. Others think it's sooner than that. That's the point when it becomes cost beneficial for the economy to start running and selling electric vehicles from that point onwards. But investors and financiers don't wait for those moments to come along. And that's the exciting thing for me that sits behind a lot of this. My optimism comes from the fact that if you look a decade ahead, that's what investors are doing right now. They're going to make decisions now about how to allocate capital. And they're going to be looking at a chart like that thinking that internal combustion engine vehicles are not where they should be putting that capital. And it's that drives progress. Surface transport today is the single biggest source of emissions in the UK. So this is our pretty conservative outlook of the cost impact of that transition for surface transport. That's not just a story that plays out in the transport sector. So as that increasingly electrified story plays out across the UK economy, we'll see more and more of these charts over time. But all of that rests ultimately on investment. So if you know all of that, let's just look at the investment requirements for net zero. And this has been the real step forward, I think, in our most recent reports. And we now have that profile of change that I talked you through in the timeline to get us to net zero by 2050. Amazing that we can now bring you these kind of insights, because what we're able to do is give you a profile of investment with it. So on that balanced pathway, what do those investments deliver and what's the requirement for investment across the economy? And if you look at this chart, what you see is that we need to scale up low carbon investment in the UK from around 5 to 10 billion today, which is mainly in the power sector, to something like 50 billion a year by 2030. So an extra investment requirement of 50 billion pounds per year from 2030 onwards. That policy challenge of scaling up over the 2020s, you can see in this chart, that's what policy needs to deliver. The policies that will deliver this are the regulatory tools, yes, a bit of subsidy, a bit of public support, but the signalling impact here of the government making clear that this is the goal. By 2030, we've scaled up investment by 50 billion a year. Net zero implies more investment across the economy, never a bad thing. That capital expenditure is what drives us to net zero. So it's the investment in renewables, it's the investment in electric cars, it's the heat pumps, it's the energy networks that go with all that. We're progressively, that story I told at the start, turning over the capital stock of the whole economy as assets come to the end of their useful life. That's what buys us net zero, but crucially it also buys us something else, which is this tremendous fuel saving that goes with it. Again, this is not a surprise, but we've not been able to model it before. So you can see that that saving, this is us not spending on fossil fuels. This is us also being more energy efficient. That saving grows over time. And actually it starts to cancel out the investment requirement altogether. So investment cost eventually is cancelled out entirely by the savings that we get from using those more electrified and more efficient technologies. So that purple chunk there is the surface transport story that I just talked about. That's electric vehicles playing out. There is a big investment requirement above the line. So think of all the infrastructure requirements, the vehicles themselves. There is a cost that comes in that purple section above the line, and a huge saving though underneath the line for making those investments. As I say, over time that cancels out. So that investment cost and fuel saving cancels out over time, and that has big implications for the overall cost. It's an amazing new insight because it means that the overall cost is much lower. And the other thing that we can do, because we have that investment data, is that we can look at what impact that might have on the economy as a whole. We did some macroeconomics with Cambridge Econometrics, and really stunning impacts there too. So in particular, over the next decade, if we make those kind of investments, it's not a drain on resources in the economy at all. We're actually, this is us using up the spare capacity in the economy in a really sensible way. So investing early over the next decade, as we recover from the pandemic, gives a boost to GDP of the order of about 2%, gets to about 3% towards the end of the transition towards 2050, when of course it's much more speculative. And there are jobs with that too. Really, really important. So I think we need to move away from thinking about this as a cost at all, actually, in terms of the whole economy question. But if we don't have that boost to the economy, it's clear that at worst we're going to have a very small cost to unlock net zero, and of course all the benefits that go with that. So here you can see that we've expressed those net costs that I showed you on that investment chart before, the cost of the investment minus the savings, and expressed that annually as a proportion of GDP. We call that the resource cost. And what you see is it's well below 1% of GDP in every year. In fact, it's more like 0.5% across that balanced pathway that we talked about. So that's moved on a lot from last year. We talked about 1 to 2% of GDP being the cost of net zero last year when we produced our work on net zero. What's driving that is the cheaper electricity prices that we got just a few months after we published net zero, so the latest offshore wind auction. Also, the fact that our assessment of what needs to be done now has less greenhouse gas removals, which tend to be more expensive for the UK. Crucial point here is that you don't need fossil fuels to access cheap energy anymore. And that overall is driving a low cost outcome. And that's really exciting. And that's before we bring in that boost to the economy that I just talked about from that investment. But, and there is always a but, really important to say that it's not some free pass here. People will experience new costs. And I think this is the best way I have of explaining that. So these need to be managed well. Crucially, we need to see a fair transition. So what this is showing you is the spread of costs across the sectors. There are some in green where we have got these cost savings. You can see the surface transport story that I've just told you about. By 2050, we expect electricity supply, if it's decarbonised, to be cheaper than if we had not put in place those policies to decarbonise electricity supply. Those kind of savings need to be spread above the line to meet the costs, particularly that you see in industry and in buildings. So in buildings, you've got the real consumer costs of heat decarbonisation. And in industry, you've got the real competitiveness problems of decarbonising industry. We need to protect the consumer and industry from some of those costs if we want this transition to be successful. And that's a big message to the Chancellor. Competitiveness is a big theme, actually, of the assessment that we've just made. We think trade exposed industries need to be protected to the tune of about £2 to £3 billion per year from their share of the costs of that decarbonisation, or we will lose that industry from the UK, which wouldn't be the right outcome. The number for buildings is probably of the order of £3 to £4 billion a year. So that's the policy challenge that the Chancellor needs to meet. Crucially, he can do that with the fiscal tools. So big message here for the Treasury in thinking about the cost review that they are undertaking right now and how you pay for net zero. Okay, last section, and this is just a couple of minutes. So I wanted to just come back to, in a positive way, how we see things standing on the global issues. This is the story I hope we're going to be hearing more about over the next year as we build up to the Glasgow Climate Summit in November next year. It may be that this reframes your own outlook because it's something I don't think a story that we've been telling enough. So let's just walk through where I think we really stand on the climate issues globally again. And we start from acknowledging that, of course, this isn't a great place to start. So we have warmed, of course, the atmosphere by 1 degree, actually slightly more than 1 degree centigrade, thanks to the things that we've been doing since industry and the use of fossil fuels that the UK led. That's leading to those really dangerous impacts that we talked about again at the start of this presentation for people around the world, here in the UK too, and the impacts on the natural environment. Every fraction of a degree from now on will make a difference. And that needs to be the way that we view this challenge from now on. But there's a really nice story, I think, playing out that isn't getting enough attention. Back in the early 2000s, when Dennis Anderson was making his big contribution to this climate debate in the Stern Review and all the various other energy forums and policy proposals that he was making and having great influence on, back then in the early 2000s, we were facing something much worse than what we are facing today. When my committee first started in 2008, global emissions were very much on the rise and there wasn't much chance of that changing. At that point, we were facing the prospect of more like 4 degrees centigrade of warming. That would probably be the central case in 2008. Risks quite easily of 6 degrees of global warming by the end of this century. That is, an astonishing and very worrying set of circumstances that led, of course, to the UK's Climate Change Act and all the efforts from the UN. We are not in that place anymore. So today, we should not expect that kind of outcome. We are making progress, especially on those energy transitions that we talked about, lower costs of renewable energy technologies, coupled with the big pledges that we're now seeing from governments around the world, the NDCs for 2030, which broadly point to a flat trend for emissions into the future globally. That's going to bring down our expected temperature rise to around 3 degrees, as I mentioned at the start, by the end of this century. 4 degrees still very much within scope, but only if the climate response is towards the worst end of our expectation from all of that fossil fuel use that we still are using. If we want to fast forward from Paris to today, then there's, I think, a more remarkable shift happening. So these net zero commitments that we're seeing from China, the EU, UK, of course, and of course the Asian economies as well now, they are going to have an impact. And I think we will probably just sneak under 2 degrees with those kind of net zero pledges. Over half of global emissions, so it's about 3/4 of the global economy in total, is now aiming for net zero emissions by mid-century or thereabouts. If those are delivered, then I think we will sneak under the 2-degree threshold that's in the Paris Agreement. That's amazing. So that's going to be, I think, the story of Glasgow next year, the net zero pledges. But we need to do a bit more than just think about mid-century pledges. And that's the importance here, to keep well below 2 degrees, which is the Paris goal. For that, we need more action now. So we need to bend that curve that you see there. Net zero pledges by mid-century are great, but we have to cut cumulative emissions on the journey. So the primary driver of climate change, of course, is those cumulative emissions. And what we do now when emissions are at their highest is the most important thing, therefore. So bending the curve is the challenge, I think, for Glasgow. And if we want to keep 1.5 degrees in scope, and I think we should, then we need to bend that curve even more. So bring the whole world to net zero by an earlier date, is looking at CO2 emissions. So net zero CO2 by 2050. That needs to be the goal if we want 1.5 to be in scope. It's going to be a tough ask, but I think that for me is the importance of the path that we've recommended for the UK. We've set out a really thorough vision of what we think the UK needs to do to get to net zero. It is based on that front-loaded trajectory, that very sharp fall in emissions. And the actions to deliver that are what really matters now. So the UK, I think, should be modelling those changes. That's the implication of accepting the recommendations that we made in our report last week. And my last slide is just to go back to that global question once more. And another take on the global challenge overall, this time looking at per capita emissions. What you can see if you look at per person emissions globally is this flat trend in emissions over the last 30 years. Again, a story that we don't really talk about, that per capita trend for the last 30 years has been flat. Emissions have been going up because the population's been going up. And you can see then again, it's another version of the chart that we started with, the Paris goals expressed as emissions reductions per capita in the coloured lines. That's the challenge per head of the population globally. And if I just, as my final slide, overlay on top of that, the story of UK emissions on that chart. Historically, the blue, light blue section that you see, we've cut our emissions per person by about half where they were in 1990 to essentially be at the global average today. Again, a remarkable story of UK progress there. We will, on the assessment that we have recommended, on the pathway that we've recommended and what I've discussed with you today, if the government accepts that recommendation, we're going to hit that 1.5 degree line per capita by 2035. And if we go on that path, that will be a story of tremendous progress for the UK. We then cross that line and get to net zero emissions even sooner than those global averages would require. And that is a story of, again, tremendous progress for the UK and something I hope to round this off that Dennis Anderson would approve of. So with that, I'd just like to say thanks and I'll hand back to you, Rob.
Brilliant stuff. Thank you very much indeed, Chris. Really enjoyed everything that you just had to say. What we have planned actually was a short break before we went to Q&A. We are running a little bit behind, and I want to make sure that we have enough time for the Q&A. So I suggest that we just take a 2-minute breather to allow you to get your breath back and have a sip of water or gin or whatever. And we'll reconvene at 3:10. Now, we ought to have enabled the Q&A. So I'm just looking at the behind the scenes elves to see whether or not they have enabled Santa's Q&A to start taking questions, and they tell me they have. So we're going to take a very short break now. Start getting your questions in. You can upvote your questions, and we're going to sort them by the number of votes they get. So it's a popularity contest for your question, and we'll reconvene in a couple of minutes. Thanks very much. So everybody, I'm going to restart. We have a slight glitch here insofar as I can't actually see what's going in the Q&A, which makes it a bit difficult for me to read any of it. One of the team has taken a screen grab, which will allow me to get started because I can at least read some of them. If we can't get this resolved, then either Chris, you'll need to chair it yourself if you can see the Q&A, or I might.
I can. My IT also dropped. I don't know if you spotted that glitch at the start there. I lost a slide at the start, and then PowerPoint was misbehaving. So
yeah, and I dropped out halfway through this. Obviously, the internet monkeys are causing problems right now. But we have a question at the top of the list I can see at the moment. It's from Paul Scholes. And it says, with regards to the upfront public engagement for behavioural change, what are the best ways to get the information and messages out to the public?
Gosh, that's such a good question, Paul, because I'm not sure there's an easy answer to it, and they're always the best questions to ask. So my experience of the Climate Assembly is what I'll turn to first. So I don't know how familiar you are with that process, but earlier this year, there was an amazing process commissioned by Parliament to bring together a representative group of people, as I mentioned in my presentation, to talk about how you achieve net zero. The crucial thing is it was 108 people who weren't there to debate climate change or the need for the target. They were there to talk about how you should achieve it. And I mentioned this last week at the launch of this carbon budget report, that I was a bit suspicious of being part of that process initially because I wasn't sure how it was going to work. So in the CCC, we are, as you'd expect, driven by the numbers. We build these technical assessments of how to cut carbon. We try and do that in a way that's compatible with that 2050 target. I wasn't sure you could ask a group of people who are naturally more value driven a set of questions about how they should deliver net zero without that kind of solid number basis behind it. And it turns out you can, and people are really engaged in that challenge if you bring them the right kind of information. So I suppose it starts, Paul, with an assessment of how we can put out useful information, not just about climate change itself. Actually, that wasn't the theme of the Climate Assembly at all. It was about the meaningful steps to cutting carbon, how those can be achieved. The message from the Climate Assembly was they wanted to know what those options were. When they had that information, they were very supportive of them. But crucially, what they wanted was some agency over it. They wanted a choice. So the kind of big changes that we'll see happen, particularly in domestic heat, big question about how we deliver a decarbonised domestic heating system for the UK. The Climate Assembly members were really keen on all of the options. Actually, they didn't have a particular favourite, but what they wanted was options that fitted local circumstances and where there was some element of local engagement over the plan. And I think that the clue in all of this is that that's the kind of discussion we need to start. We don't need to talk about so much climate change, more about the practical steps. And again, I don't think we're being honest with people in the UK unless we start properly having that kind of discussion. That's real engagement. And it's in that we'll find the real delivery questions, I think. So it's something that I'm excited about the CCC doing more work on in the future as well, is those more kind of deliberative processes that might help us understand that into the future. But I'll be honest with you, I don't have all the answers to that question. I just know that we need to do it. Yeah,
it's a really, really tricky one. And it's certainly one that that we're engaging with from the research side of things as well, and that kind of two-thirds of that pie chart of yours, or so, or over half at least, had something to do with behavioural change. Okay, so I'm going to switch topics. I'm still slightly being hindered by the technology here, but I have some of the questions being kind of pushed through to me via the chat. Another very important and very big question that's got lots of votes, and it's about embodied impact or embodied carbon, Chris, which I know that you have thought about and spoken about before. So the question, which was anonymous, says, how are embodied impacts being accounted for? For example, if you're rolling out mass production of renewable technologies that get manufactured in China and the energy mix there is still much more carbon intensive, then how should we account for those emissions?
So such a vexed question, isn't it? So to go back to the UN process requires that each country takes responsibility for its territorial emissions, and that's essentially what the Climate Change Act is built around. So we've had 12 years of advising on how the UK should reduce its territorial emissions, but that's clearly only one part of the total story of what the UK is responsible for. So we do need to think, I think, in a broader sense about the changes that go with that and what the UK is responsible for in other parts of the world, and those, especially those emissions that we import and those that we export from the North Sea, especially. And we in the CCC have been building a more rich understanding of some of those carbon footprinting issues. One of the commitments that naturally didn't get much coverage last week is that we're going to start tracking that actively with a key set of metrics. And behind that is this idea that the world is on a transition to the Paris goals. And that will bring with it a reduction in the total carbon footprint that the UK is responsible for. So we think that by 2050, 90% of UK consumption emissions will have been reduced to zero if the world goes on the kind of transition it needs to go on to meet the Paris goals. Now that follows quite obviously from the charts that I showed you. But we need to do a bit more than that. I think there is a role for policy. You could think about carbon border adjustments, for example, as a potential policy that the EU is thinking about, a way of applying a higher carbon tax on imported goods from those areas if we haven't seen low carbon production processes. I think there's also a question of what the UK might do if the EU goes down that route. But the other part of this is that in reducing our territorial emissions, we will naturally reduce our imports of some of these things too. So implicit in the net zero story I've just told you is a reduction overall in the resources that we're consuming. And that will help on that process overall. But I don't want to dismiss it because I think it's ultimately we are responsible for more than just the territorial emissions. It's just that at the moment they are still the largest part of the total carbon footprint that the UK is responsible for. I think it's therefore appropriate that we have a target that's based around territorial emissions, but you can expect us to look at the broader issues going forward.
Yeah, completely understand all of that, and it's often a subject that I find myself discussing with students. Actually, this seems to be something that really engages people's attention. And there was a second question. I'm still having these pushed through to me, but it seems to be working fine. Actually, there's another question around emissions simply being exported, which I think you've addressed. So I'm gonna move on. I've got a question here from John that says that EU, Dutch, German hydrogen strategies see low carbon hydrogen as important up to 2030, by which I think John means hydrogen from CCS, but then phasing out in favour of zero emission green hydrogen, which I take as being principally hydrogen from electrolysis from renewables. Does the CCC still see an important role for CCS/low carbon hydrogen in the 2030 to 2050 period?
Yeah, so there's a really important question about not just building the hydrogen demand that we think we will have in the future, but crucially a question of how it's then supplied. So basically the story here is that we start with blue hydrogen. So we build these 5 CCS clusters, and we probably need a handful, possibly more, where we're doing that carbon capture. That's important because it means we can continue low carbon industry in those places. It means that we can also produce hydrogen from natural gas and safely store it under the North Sea, and we do believe that's a credible process. But what we see over time is that we move from blue hydrogen to green hydrogen. So green hydrogen becomes the dominant source of hydrogen by 2050. And we think it's possible to go even farther than that. So in the innovation scenario, we have a lot more electrolysis. It's wedded quite closely to the offshore wind story in our analysis. So where we have wind that would otherwise be constrained off, we are increasingly turning that to hydrogen and storing it as hydrogen in our power modelling. So we move that story progressively, but it does start with blue hydrogen and CCS, and I think that the jury's out about how that process should take place. The UK has an unusually good potential for carbon capture and storage, and therefore we think it makes sense to get going on that. The thing with CCS more generally is that it's a really good thing to have in your toolbox. It opens up the options, and it means that we can talk about some of those alternative futures. If you don't have it, you're into quite a narrow set of options to get to net zero. We do have a scenario. In the tailwind scenario, if you look in the document that we've just published, we get to net zero by 2050 without CCS under the same conditions that you see in the tailwind scenario that I talked about. But my God, it's tight. So you're really down to single routes for most of the decarbonisation options across the economy, and it's not really a future I think we should be pointing ourselves towards, because without that CCS insurance, it's really bloody difficult to get to net zero overall, and you have to expect therefore that we would fail to get to net zero by 2050, which is very much the target that we should have for the Paris obligations. So CCS opens up that set of prospects to go in different directions across the economy. It's potentially a way of building a hub for CCS for the UK, which could in itself be an industry as well, a global hub for CCS. That's not an option that we are proposing here, but that kind of option isn't on the table unless you start to develop the industrial expertise to do it and the clusters for CCS that we think are necessary.
Okay, that's good, Chris. I mean, just to clarify, thinking about exactly what's in the question, it sounds to me as if some other countries might have a kind of deliberate strategy of moving away from blue hydrogen to green hydrogen, because green hydrogen is kind of purer, you know, there's a kind of ideological preference. That's not what you're saying, is it? You're saying that it becomes that the model chooses to use more green hydrogen because it has more system value.
I think that's the system modeler's answer, but yeah, there is a bit of policy direction in there too. So when you have that, then when you have offshore wind at the extent that we're predicting we would have, then it becomes quite sensible to use it for electrolysis into the future. The key condition on whether you're electrolyzing or using CCS is price. So the innovation scenario that I talked about has a very cheap power price, and in that scenario, electrolysis looks better. So you know that it's a zero carbon process with a cheap power price. It's something that you would actively choose to do. The other wild card here is whether we're importing it. So we potentially could be importing cheap hydrogen from places that are producing it from zero carbon means. Of course, Moroccan hydrogen is sometimes talked about. Again, that's a price issue. So we do have that coming in by mid-century. So we've got some importation of hydrogen as well. So in the end, it's a combination of the modelling, of course, but also the underlying economics moving towards it.
Great. Okay. Conscious of time, I could spend more time on that one. It's a very, very important question. There was another question about the offsetting and the economics, and a carbon tariff on imports. I think we've probably more or less covered that. So I've got a question here from Helena. What role do you think the fossil fuel sector will play? Is there a role for them at all?
Well, we think there is a role, but it's a diminishing one. And that's probably the biggest, that's another one of the big changes from our report last year in net zero. So we actually had quite a lot of fossil fuel use in 2050 in last year's report, which didn't sit well with me, if I'm honest. So worth saying that last year what we're trying to do was slightly different from the report this year. Last year we were trying to demonstrate that net zero was the right target, and we did that by deliberately trying not to rock the boat too much. So we had quite a lot of fossil fuel use, but with carbon capture, especially gas. This year's report does cut our gas use quite significantly. So we've got 70% fall in natural gas consumption, 85% fall in oil in the balanced pathway. That points to a smaller oil and gas sector, but that is in any case where we are pointed. So I mean, I don't really see that's a huge change, I suppose, in outlook. But again, if anyone here is representing oil and gas, or if they're in that industry, I think the challenge is to them. There is a world where we do use more oil and gas with carbon capture. That process is not zero carbon, so you have to work harder somewhere else if you want that kind of future. What's coming out of our analysis more and more each year as we renew it is that isn't necessary anymore. That actually you can have that more electrified future that we talked about, and indeed more use of hydrogen with electrolysis in the future as well. And that is now out-competing, even today, that future with fossil fuels. So that, I think that's the challenge to the fossil fuel industry is if you want that kind of process and outlook to be the place where we end up, then you're going to need to make carbon capture work, and it needs to be cheap. Alternatively, better outcome from my perspective is let's start talking about switching from fossil fuels to these cleaner energy technologies in the round, and that seems to be a strategy that's working very well for some of those old oil and gas majors that you've seen, Dong, for example, and others who've moved entirely from fossil fuels onto low carbon fuels, and that are having much more success doing so. I'm really interested in what BP and Shell are doing at the moment. The two companies, of course, that are very topical in the UK, and they seem now to be genuinely embracing that transition. We need, in the end, to move away from fossil fuels, and that's what's coming out strongly in this analysis, that pace of progression is happening more and more, the quicker and quicker each year. And it looks to me like an industry that needs to make that transition itself. Okay,
Chris, that's really interesting. And there's obviously a potential both upstream and downstream for those businesses. I think we saw some news around a charging station forecourt that's opened. Just for example, which is they've had profitable downstream businesses, of course, and there's a role there. So again, something we could talk about longer. And I'm sorry for all, there's people, there's questions piling in, and probably people responding to some of the things that we're saying. And I just, with hundreds of people on the event, I can't do justice to your fantastic questions. But this is a good one. I think it might be the last one we have time for. Has the committee considered how to counter distrust of climate science experts and politicians? Not necessarily the people you discuss in the Climate Assembly that are not really aware of the fact they might have to get rid of their boiler, but people whose worldview is at odds with experts.
Short answer is yes. I mean, this is really the job from my perspective. So we deal with this every day, and I think it's worth just reflecting, since we were talking about Dennis Anderson and his role in the early 2000s. 2008 was when the Climate Change Act came about, and with it the Committee on Climate Change, as it was then. And then we were talking much more about a much more oppositional discussion about climate change itself. Is it happening at all? It was a kind of regular debate that you were hearing in the media and even amongst the policymakers. That's the world that the CCC was born into. Today, and again, this is very subjective, we're not in that world anymore. So it's rare now that you meet someone who thinks that climate change isn't happening, and it's rare that there isn't an acceptance that it is being driven by the human activities that are taking place around the world. Now you get a more interesting discussion, the kind of lukewarmers, as they're sometimes referred to, that accept that it is happening, but either that it's beneficial, which I think is a very hard argument to swallow, or much harder argument to deal with, that we should wait to fix it, that somehow technology will come along to address that challenge. That's the one I think we deal with most now. And there is an outlook on one of the things I've just presented that says, well, given the fact that innovation is happening at pace, and given that cost falls are predicted in the key energy technologies that will drive that decarbonisation, why should the UK go early on it? And I think that ignores the underlying issue that it is because we've acted that you see that happening. It is because the policies were put in place that you see that market response, that scale manufacturing. That's not just a UK story, but just think about the UK for a second. The offshore wind story, which is driven in large part by UK policymaking, is an amazing story of the UK driving progress on a key technology that the world will benefit from. That is a really good example of why it's important to act early on this, why it's important to front load those emissions reductions, because the benefits in terms of the technology and the cost reductions accumulate by acting early. So I think that's the one that we struggle with most and every day think about. And we see that playing out a lot amongst parliamentarians. There's often a kind of US outlook on that technology challenge that can be difficult to argue with. But ultimately, our view rests on the fact that firstly, we have this cumulative problem of emissions that we have to act on quickly. The UK needs to be part of that. And secondly, that the benefits that come from acting early are not just about climate change itself and carbon, but also those innovation benefits, markets that open, technologies that develop, because we have acted soon. And I think that's the key thing for me, is that's what's going to continue to keep progress on the road, is by front loading the ambition.
Okay, Chris. I mean, it brings us nicely back to Dennis, because one of his mantras was that technology doesn't come as a manna from heaven, and that if you want to get technological progress and low carbon, then you have to put your shoulder behind the wheel and push technology in that direction. That's everything that we know about how technological change, and probably applies equally to behavioural change. There's loads of good questions. I would love to carry on going. We are already over time. I think we've taken up already an hour and a half of your time, so I think I have to draw it to a close there, sadly. Just to say before we do close that there's a recording of this that's going to be on the Energy Futures Lab YouTube channel. I don't know how quite you find that, but I'm sure you can find it by the wonders of Google. And obviously your website's got a wealth of wonderful stuff around the sixth carbon budget and supporting analysis and all the rest of it. So I don't think there's anything else for me to say other than a huge vote of thanks to you for giving up so much of your time, Chris. I've really enjoyed it. And also just to congratulate you on your lovely Christmas tree and bookshelf backdrop. very much more festive than the back end of the garden shed that you can see behind me. Tim, is there anything that you just wanted to say in closing from Energy Futures Lab side of things? Can't hear you, Tim. So if it's a no, if it's just a no, just shake your head. Okay, I think
I can't unmute.
Okay, we can hear you.
Oh,
I can hear you.
Unmuted. Sorry. Really, just want to say, Chris, that was fantastic. Thank you. A tour de force and a great presentation. And thank you for being so generous with your time on that and indeed answering the questions. Thanks again.
Yeah, and it's thanks from me as well. I think the event will end. I don't actually know how to end the event. But thanks to everybody for who's joined in, all of the people that set questions. Apologies again to those that we didn't get to, and thanks to Chris. Happy Christmas.